All right, so this is another example of when we're solving for an angle. So angle A is this angle over here, and let's see what we have. Directly across from angle A is 5, so this is the opposite side. And then as it relates to angle A, this is 8, and this is the adjacent side. And of course, the hypotenuse is always across from the right angle, which is why this side is referred to as the hypotenuse and not the adjacent side. So going back to our SOHCAHTOA, what do you want to use? Well, we have the adjacent side and we have the opposite side. So that means we need to use the tangent, and I don't know what this angle is, but we're just going to go ahead and call it angle A. And I know that the tangent of A is equal to the opposite over the adjacent, the ratio of those angles. Now, normally we go ahead and use the trig function to find this particular ratio, but whenever you are looking for the angle of the trig function, what you need to do is we need to take the inverse of that function. So the inverse will find us what the measure of angle A is. And remember, again, that's not an exponent, which is -1. It will never equal 1 over the tangent of 5/8. That's something else. We don't use that. That is not what that means. It means it's the inverse of the function. So if I plug that into my calculator, you're going to go ahead and get that the measure of angle A is equal to 32.005 degrees. All right, so we're going to go ahead and now find the length of this triangle, which is y. Now, in relation to this, y is always going to be called the hypotenuse. If we look in reference to angle that we're given, our angle that we're given here is 74. So directly across from that, or the opposite of that, is 128.6. Make sure I have that point in there so you can see that clearly. That should be 128.6. So let's go ahead and set that up. Again, because of SOHCAHTOA, we want to go ahead and use the fact that I know that the sine of 74 degrees is equal to 128.6 over y. I get y all by itself, and I get y is equal to 128.6 divided by the sine of 74 degrees. Put that in your calculator just as it is, and you're going to go ahead and get that this is equal to 133.7825. We want to go ahead and round this to 3 decimal places, or the thousandths place, which means we're going to round up in this case, which will give us 133.783. And there's no units in this. We're just going to go ahead and write that as units. All right, the last one for this particular page on the notes, the last example that we have on this page of the notes is angle B. This side length is 70 and this side length is 42. So as both of these relate to this angle B, this side going directly across from it is the opposite side. This is the hypotenuse. Let me just put my right angle in there. I absolutely have to have that. If for any reason that angle sign is missing for a 90-degree angle, you cannot assume it, and you have to use a different method of solving that. But that is the next lesson. So to set this up, again, with SOHCAHTOA, what do we have? We have the opposite side, and we have the hypotenuse. So the trig function that uses both of those tells us that I need the sine of beta is equal to 42 over 70 degrees. And again, because we are looking for the angle, the inverse sine of the ratio of 42 over 70, that will equal the measure of the angle. And when I do that, I get angle beta is equal to 36.8698. Be careful with this one, with rounding, because if I'm looking at the third decimal place here, that would round that up to one more, which would be 10, which changes this into rounding the next decimal place up, which gives us that angle beta is equal to 36.87 degrees.